Finkelstein.com.
Okay, students, now we are going to start with the new topic, and it is a new system making the NCRT short notes. So most of the students are in hurry to understand lot of things in very short span of time, and they don't have even time to refer the NCRT also. Okay, so this type of notes will be very helpful to them. Okay, so this NCRT short notes is made by the filtering the NCRT to the VIJ CHEM filter. Okay, so these short notes will be very handy, and I have used only NCRT, and I have shown you the reference of NCRT. And in this session we are going to study about the all the naming reactions in the syllabus from the haloalkanes and haloarenes. Okay, so let's get set. So this is the NCRT. Okay, and our class is going to be the filter. So our class is going to be the filter to NCRT, and you can make a juice and enjoy the juice of naming reactions. So get set ready for the one by one reaction. Okay, now let us start with the first naming reaction. First naming reaction of the haloalkanes and haloarenes. Okay, this is a extract or filter of the NCRT. So nothing is out of the syllabus. Every word is in the syllabus. Okay, the main problem with the NCRT, people are not able to understand the language used by the NCRT. So that's why I picked up the paragraph from the NCRT only, and I'm going to explain. Once you use the NCRT, CBSE people will mesmerize, and they will give you the good marks. And if you understand the internal meaning of that paragraph used, then definitely you are going to tackle with the both NEET and IIT examination objective questions also. Okay, so let's start with the Sandmeyer reaction. Okay, so in every reaction, three things. In the end of the session, I will provide you with one tabular form, which will be a summary of the all reactions which we are going to study. So while studying itself, we should make sure. So what is the reactant in that reaction? Okay, every naming reaction, you should identify what is the reactant and what is the substance produced out of that reaction and what is the reagent used for that reaction. And it is not necessary. Okay, reagent is optional. If the reaction is not able to start on its own and cannot proceed with the high speed, then we will use with the reagent. Okay, so if you mention these three things accurately, definitely this is equal to three objectives. Three objective for the entrance examination, and for the board examination, half point, and half point. And when you write the reaction with these sentences, then half point. So 2 marks will be definitely you will be getting. Okay, this is the marking scheme of the board examination. Okay, so let it be state board or let it be CBSE. Everywhere marking scheme of the naming reaction will be same. So that is why you are using the both edges in the time where you are going to prepare common for the entrances board exams. Then this is the best method. Okay. So first of all, when a primary aromatic amine, that means reactant is what? Primary aromatic amine. So what is amine? NH2. Okay. So nitrogen is a trivalent. Nitrogen is what? Trivalent. On that, if two places are hydrogen, only one place organic substance, then it is called as a primary amine. Okay, and that primary amine organic substance is benzene ring or derivative of the benzene ring. Then it is called as a primary aromatic amine. So this primary can also be represented as 1 degree. It is also called as 1 degree. That means one alkyl group is representing. Okay, 1 degree means one alkyl group. Okay, so when a primary aromatic amine dissolved or suspended in a cold aqueous mineral acid, okay, mineral acid, and is treated with the sodium nitrite. See, very carefully you have to do ITE. ITE means NO2, okay. If it is ATE, that time it will be what? NO3. So once it is ITE, you have to be very careful. NaNO2. Here it is a mineral acid. Understood? So reagent, here reactant is primary aromatic amine, and reagent we are using is sodium nitrite in mineral acid HCl. Okay. A diazonium salt is produced. The product will be diazonium salt. So here name is very important. Di means two, azo means nitrogen, plus minus is there, that means it is salt. Okay. So this is called as a benzene diazonium halide. Benzene diazonium halide. So chlorine or bromine. Here we are using the X. X can be chlorine or bromine. Okay. So the mixing the solution of a freshly prepared diazonium salt with cuprous chloride. Okay, diazonium salt with cuprous chloride or bromide result in the replacement of diazonium group by the chlorine or bromine. Okay, so Sandmeyer reaction, I think it is clear now. So this is the complete reaction. Okay, benzene diazonium chloride, then we will react it with the cuprous chloride Cu2Cl2, okay, or CuBr. Then that chlorine, here this halogen will be exchanged, that we are going to see now. Okay, so this is Sandmeyer reaction. Make a clear note of it. Already it is a short note, and if you understand every word it will be useful. Okay, so let's see the next one. Okay, here first we prepared what? Benzene diazonium chloride. Okay, so after that the further reaction, cuprous chloride. So this is what already I have explained. Then this benzene diazonium chloride treated with the Cu2X2. Okay, here X is the halogen. It can be chlorine or bromine. And what it is called as cuprous chloride. Cuprous chloride if chlorine is there, bromide if bromine is there. So then now this completely N2 will be out from the N2, out from the benzene ring. So aryl halides are prepared. Okay. So this reaction, what is the reaction name? Sandmeyer reaction is used for the preparation of aromatic halides. Okay, all are aryl halides. We can say it as what? Aryl halides, for the preparation of aryl halide. Okay, this is aryl halide. Understood? So now I am writing the complete details. What is the reactant? First reactant is simple aromatic primary amine. 1 degree aromatic amine. Okay, actually this is used for producing aromatic amine. Okay, 1 degree aromatic amine that will be further converted into diazonium salt. Okay, diazonium salt. Then it will be converted into aryl halide. So if you are not remembering, at least you have to remember this part. This is the main equation. Okay, so this is what Sandmeyer reaction. Okay. Okay, after noting down this short points, then let us start with the next one. Okay, this is about the chlorine and bromine. Now we want if the thing is to be replaced for the iodine. Okay, replacement of diazonium group by the iodine does not require the presence of cuprous halide. So it is done simply by shaking the diazonium salt with potassium iodide. So if I use Cu2Cl2, okay, then chlorine will be replaced here. If I use Cu2Br2, then bromine will be replaced. But for iodine, we have to use Ki. Okay, so product reactant is same. First, primary amine treated with the NaNO2 oblique HCl to prepare the diazonium salt. So that diazonium salt is basic requirement for the preparation of haloarenes. And if you want chlorine, you will use Cu2Cl2. If you want bromine, you will use Cu2Br2. If you want iodine is to be replaced, then Ki. This is the Sandmeyer reaction for the three haloarenes. Three haloarenes are chlorobenzene, bromobenzene, and iodobenzene. Okay. So this is about the Sandmeyer reaction. Now let's move on to the next reaction. Okay. So next naming reaction is Finkelstein reaction. Okay. So Finkelstein reaction is basically preparation method of the alkyl iodide. Preparation method of what? Alkyl iodide. Okay, iodides are often prepared by the reaction of the alkyl chlorides or bromides. Main problem is that whatever the major methods we have, they are either for the chlorines or for the bromines. We are not able to prepare the iodides because of the less reactivity. So when you use the common methods for preparation of Ri, that is reversible and it is time taking. And nowadays, the time is money, time is life today. Okay. So if you want that iodoalkane is to be prepared in the fast track, then the fast track reaction is Finkelstein reaction. Okay. So, but before that, we should prepare the alkyl chloride or alkyl bromide before the alkyl iodide. Then only we can use the Finkelstein reaction. Okay. Now, treated with sodium iodide in dry acetone. In the dry acetone, this reaction is known as Finkelstein reaction. Okay. So, X is equal to Cl or Br, it is possible. And here, see, NaX will be formed and Ri will also will be formed. So they are to be separated. Therefore, is precipitated in dry acetone. Why dry acetone is used? Because they are not soluble. Whatever the NaX is there, whatever the NaBr, NaCl will be there, that will be already precipitated. Okay. So once one of the product is removed, then the reaction will go in the forward direction. That means we are going to get more and more alkyl iodide. Okay. So that is the Finkelstein reaction. Now you have to extract the juice. What is the juice? Reactant. Okay, what is the reactant over here? Reactant in the Finkelstein reaction is alkyl chloride or alkyl bromide. Okay, then what is the reagent required? What we have used here? Two things we have used: NaI, sodium iodide in dry acetone. Sodium iodide in dry acetone. Okay, and what is the product here? Our ultimate product, main product is alkyl iodide, and we are getting as a byproduct sodium halide. Understood? So this is about the Finkelstein reaction. So sometimes people, once they study Finkelstein reaction, they forget the Sandmeyer reaction. Sandmeyer reaction is preparation of the haloarenes, alkyl iodide, aryl iodide, aryl chloride, aryl bromide can be prepared. Diazonium salt will be the basic reaction, and for cuprous chloride or cuprous bromide for the bromobenzene, bromochlorine or chlorobromine, then bromobenzene or bromochlorobenzene. Then for iodine, we will use potassium iodide. Okay, so once you study the new thing, don't forget the old thing. Okay, so I think it is clear now. Now, okay, this was the second naming reaction. So once you do the all naming reaction, at least from the NCRT, so 2 marks, 2 to 4 marks will be in your pocket. Now you have to rest all year. You will study for the remaining marks only. Okay. Now let's start with the Swarts reaction. Okay. So Swarts reaction is for fluoride. There are only two people in the halogens problem. Okay. Fluorine, chlorine, bromine, and iodine. Okay. Iodine is too lazy. It will always carry out the reaction very, very slowly. We have to force the iodine, do the reaction, and we have to stop the fluorine. It is violently reacting. This is over smart, this is under smart, and smart people are only chlorine and bromine. So for this only we have the previous reaction, Finkelstein reaction. Okay, and for this we have the new reaction called as a Swarts reaction. Okay, so what is Swarts reaction? The synthesis of alkyl fluoride is best accomplished by the heating of again alkyl chloride and alkyl bromide. So prepare these 2 from any other method. Plenty of the methods already mentioned in NCRT. Okay, so by using them, you will prepare the chloro or bromo. But naming reaction, you need not to mention. Whatever the four things I have mentioned, that is reactant, what is the reactant, what is the product, what is the reagent, and total balanced reaction. That's it. Okay. So bromide in presence of metallic fluorides such as AgF, Hg2F2, COF2, SbF3. Then the reaction is termed as Swarts reaction. Okay. So here this can be, here I have taken an example of AgF and we can take HgF2 also, COF2. But these must be less reactive because we are worried about the over reaction of the fluorine. So at least we will add that halogen with the less reactive metal. Okay. So then CH3Br. Okay. So here it is not necessary that bromine will be there. You can keep it a chlorine also. So CH3Br or Cl plus AgF when treated with CH3F will be formed. Simple. It is just like a double displacement reaction or exchange reaction. Okay. Now the question is summary juice. Okay. So what is the reaction? Reactant. What is the reactant? Chloro or bromo. Chloro or bromo alkane is the reactant. Chloro or bromo alkane is the reactant. Okay. And what is the product here? Fluoroalkane. Fluoroalkane. FLUORO. Okay. FLUORO, fluoroalkane. And what is the reagent we are using? We can use AgF, we can use Hg2F2, we can use COF3, or we can use SbF3. And this reaction is called as a Swarts reaction. Okay. And iodoalkanes are prepared by the Finkelstein reaction. Fluoroalkanes are prepared by the Swarts reaction. Haloarenes are prepared by the Sandmeyer reaction. Three reactions we have studied. If you study third reaction, don't forget first and second. Okay. So this is the third name reaction. Okay. Now let's move on to the next one. Okay. After this, now we are going to the next reaction. Next reaction is very, very famous, very useful reaction. Not as a naming reaction, but also for the conversions. Okay. In the organic, very, very famous conversions reactions are there. So there you will find the Woods reaction use. The simple technique you will use Woods reaction is wherever you find that product number of carbon atoms in the product are double the reactant. Simply it will be done, that reaction will be done by the Woods reaction. Okay. So here Woods reaction, alkyl halide react with the sodium in dry ether. Sodium in dry ether to give hydrocarbons. So this already we have studied in the class 11th, preparation of hydrocarbons. Okay. So organic, there is one advantage. Everything you will study minimum to minimum 2 times. Why? Because see here, this we have studied in the preparation of hydrocarbon, and here we have studied this in the preparation of hydrocarbon. Again we are studying in the properties of hydrocarbon. Okay. So sorry, haloalkanes. Understood? So everything you will study at least 2 places in the organic, in one preparation and another properties. Okay. So alkyl halide react with the sodium alkyl halide. That means reactant is alkyl halide and react with sodium in dry ether. Okay. So the reagent is required is dry ether is required reagent to dissolve the sodium. Okay. Containing double number of carbon atoms present in the halide. So the product will be the hydrocarbon. If you have propyl chloride, you will get the hexane. If you have butyl bromide, you will get the octane. Number of carbon atoms in the product hydrocarbon will be, number of carbon atom in the product hydrocarbon will be just twice the number of carbon atoms available in the haloalkane. Okay. So now let us make the juice out of it. Reactant. What is the reactant? reactant, haloalkane. Okay, haloalkane is the reactant. And what is the reagent? Sodium in dry ether. Sodium in dry ether is the reactant. Sodium in dry ether is the reactant. Okay, sorry, reagent. Understood? Now product is the hydrocarbon with twice the number of carbon atoms. Products are hydrocarbon with twice the number of carbon atoms available in the respective haloalkane. Okay, so I think it is clear now what's the reaction. Let's start with the next one. Okay, next to very famous and very useful reaction. The advantage of this reaction is you will use it in almost all chapters, not only in chlorobenzene. You will also use it in alcohols. You will also use it in aldehyde. Everywhere you will use this reaction. That is Friedel-Crafts alkylation, and there are total three types of reaction. Okay, Friedel-Crafts alkylation, Friedel-Crafts halogenation, Friedel-Crafts acylation. So, but already halogen is there. In this, we are going to study alkylation and acylation. Okay, so let's start with the first one, Friedel-Crafts alkylation. Okay, so in the Friedel-Crafts alkylation, you are taking the chlorobenzene as a reactant. Okay, reactant is what? Chlorobenzene. And here it is not necessary that it will be methyl chloride only. It can be any RCl, any alkyl chloride or alkyl halogen also, no problem. This can be bromine also, no problem. This can be ethyl propyl also, no problem. Okay, but this word is necessary, anhydrous AlCl3. In presence of what? Anhydrous AlCl3, then this methyl group will be substituted either at ortho position or at the para position. Okay, so what is ortho, meta, para? There are three active positions. I will mark out it here so that from the basic I want that your organic must be strong. Okay, so this is the benzene. Okay, now if I substitute one group here, this is called as a mono substituted benzene, and there will be three active sites over here. How many active sites? Three active sites over here. Okay, so this one and this one. Okay, so this blue tick represents that is a ortho position. What it is called as? Ortho position. Okay, now if I tick this one and this one. Okay, this green tick shows that it is a meta position. Okay, and there is only one and only one left over. Let me mark it with the yellow. It is visible. Yes. Okay, so this yellow represents that para. Okay, yellow represents that para. So in mono substituted benzene there will be three active sites. Okay, types of active sites are three, but not that number of active sites are three. Number of active sites are five, and types of active sites are only three. Okay, or two ortho, two meta, and two para. So don't forget the sequence ortho, meta, para. Okay, how you will remember this ortho, meta, para? Take Bhagwan Shiva's name. Okay, you will take Om Parameshwara. Okay, so Om Parameshwara means ortho, meta, para. Okay, ortho, meta, para. This is the memory trick to remember the location or active sites of the mono substituted benzene. Om Parameshwara, ortho, meta, para. Okay, so now it will be uh, here. This is a chlorobenzene. Okay, so on this chloro, first, second, 1 chloro, 2 methyl benzene, and this will be 1, 2, 3, 4, 1 chloro, 4 methyl benzene. In this, you can see here, this will be minor product, this will be major product. Okay, so minor product because of the steric hindrance. There will be steric repulsion between these two, and there is a ample space. They can freely available. Once you are freely available, that means you are trying to attain that freeness. Okay, that is stability will be improved. I think it is clear to you now. Now, are you ready for going to the next level? Okay, so this is a Friedel-Crafts alkylation. Let me make it juice for you. Okay, so in this Friedel-Crafts alkylation, what is the reactant? Reactant. Reactant is haloarene. Okay, haloarene. Understood? And what is the reagent? Reactant is haloarene. Okay, and reagent is the most and most important. What is that reagent? Anhydrous. Anhydrous AlCl3. Okay, then product. What is the product? That is the main thing. Okay, product is alkyl haloarene. Okay, alkyl group will be substituted here. This can be ethyl, this can be propyl. Okay, alkyl haloarene. Okay, that is the major product. I think once you know these three things comfortably, you can frame a wonderful sentence and project yourself in the board exam and come out with the confidence that you will get a good percentile marks. Okay, so now let's see the next one. Okay, next one more type of reaction in the Friedel-Crafts only, that is Friedel-Crafts acylation. Okay, Friedel-Crafts what? Acylation. Acyl group means CH3CO. Acid halide is shortly known as the acyl group. Okay, so these are the top secret I reveal only to my students. Okay, so acid halide. Actually, this is acid only, but in that acid, OH is replaced by the halogen. That's why this is called as a acyl halide. Okay. Simply this hydrogen, this what is the place at ortho and para. Okay. So there is a wonderful question also, that also I will discuss, so that along with the naming reaction, you will be perfect in the conversions, you will be perfect in the concept based question, reasoning questions also will be there. Okay, you can go through the previous question, definitely you will understand this type of questions now. Okay, so this either play hydrogen at the ortho position or hydrogen at the para position will be replaced or will move out with the chlorine, and this will be substituted over here. Okay, so now you see here this chlorine is becoming as a substitute acetophenone. Now this is the major chain. This is what? Acetophenone. And on this one, two chloro. Okay. 2-chloroacetophenone. Here numbering is starting from here. So 4-chloroacetophenone is the major product. Okay. So reactant is same haloarene. Reagent is uh, acid halide in anhydrous AlCl3. And what are the product? Haloacetophenone or halo 2 haloacetophenone or 4 haloacetophenone. Okay, this is the Friedel-Crafts acylation reaction. Okay, it is very simple if you understand the Friedel-Crafts alkylation. Okay, next topic is concept building. As I told you, I promised you, then mostly I keep my promises. Okay, so concept building question, CBQ. What is it says? Although chlorine is an electron withdrawing group, yet it is ortho-para directing in an electrophilic aromatic substitution. Okay, so actually chlorine wants the electron. Okay, and electrophile is coming on the ortho and para position, and when it is a electrophilic aromatic substitution, in entrance exam they will write as a EAS, short form they will write. EAS means electrophilic aromatic substitution. Okay, so what is the reason behind it? Chlorine withdraws electron through the inductive effect. Okay, there are two types of effects shown by the chlorine, and both are opposite. Not only chlorine, actually it is with everybody, halogen. Okay, so it will withdraw the electron from the sigma bond. It will withdraw the electron from the sigma bond. This is what it is represented now. Okay, and releases electron through the resonance. Okay, so it is very good person. Okay, so it will lose its lone pair and it will gain the sigma bond electron through this. Okay, from the inductive effect it is minus I, but for the resonance effect it is plus R plus M. Okay, So though inductive effect, chlorine destabilizes. Okay. So actually halogen is like father. Okay. Father, when you ask mother, when you ask money, what he will say, no, I don't have. Why you are wasting the money? Okay. Like inductive effect. But afterwards he will say to your mother, give it and don't say that I have given the money to them. Like that, this will lone pair donated to the benzene ring, but it will not do directly. Okay, so it will do indirectly. It appeared to be very conjuice, or we can say uh, very harsh person for the inductive effect, but once it donates to the lone pair to the resonance, that time it will be plus m effect. Okay, so through the inductive effect it destabilizes, but it is stabilized due to the mesomeric effect. Okay, so the carbocation formed during the electrophilic substitution. Now let's see the diagrammatic explanation of this. Okay. Okay, here is the mechanism. Mechanism, don't worry. Mechanism is not a rocket science. It is very easy. Okay. So electrophile, electron attracting. Electrophile means electron attracting. Okay. So electron attracting, and that chlorine, because of this lone pair, it will be transferred over here. So at this place you will find hydrogen and electrophile. Now total lone pairs will be, this is the carbocation, this is what carbocation. Okay, so this otherwise you can say that positive charge moved here, electrophile attached here, but see, this is the inductive effect. Through the sigma bond, inductive effect will be there. Okay, so but through the resonance effect, see here, through the resonance effect, this is been stabilized now. Okay, so that's why, and the electrons are more available at where, at the ortho position, and electrons are more available at the para position only. Okay, so when electrons are donated by the chlorine, they are more available at ortho position, more available at the para position. That's why electrophile will come for electron only. So electron is available at what positions? Electrons are available at ortho position, and electrons are available at the para position. That's why even though it is electron withdrawing through the inductive effect due to plus resonance effect, plus R effect, electrons are more concentrated at ortho and para position. Therefore, it is substituted at OP directing. Okay. So that was the concept building. Okay. Okay, this is what I have told you. And if you want, take a screenshot and make a notes. Handwritten notes are very, very important. Even though printed notes are good to understand, but not good for memorizing. Okay, so rely on your own handwritten notes. Okay, next reaction is Woods fitting reaction. Okay, already we have studied Woods, so the same thing you will be adding here, not copy pasting. You will be adding here. Okay, so Woods is favorite is alkyl group. Fitting favorite is aryl group. Fitting favorite is which group? Aryl group. Okay, so here you will, because of the fitting, aryl halide. Okay, and because of the Woods, it will be alkyl halide. So one side alkyl halide, another side aryl halide. I think aryl halide means anything halogen attached with the benzene ring is called as a aryl halide. Anything halogen attached with the aryl group, then it is called as a aryl halide. Okay. So this is the reaction between them and ether. In presence of ether, this reaction will be done. And here we cannot say it is double because both groups are different now. Okay. So same thing, Woods fitting reaction is also same. So the reaction of alkyl halide and aryl halide, that is the reactant, in presence of sodium dry ether to give aryalkyl group. Okay, one side it will be hydrocarbon only, alkyl arene will be formed. Okay, that is the product produced. Now I think it is clear now. Now let's move on to the next part. Okay. Okay, next to it is fitting reaction. Very simple. Fitting is for only aryl halides. So two aryl halides undergo reaction in presence of sodium triether to form two aryl group attached together. Okay, so that is called as a Fittig reaction, same as a Woods reaction only. In Woods reaction, alkyl halides. In Fittig reaction, aryl halides. And in Wood fitting reaction, alkyl and aryl halides. Okay, I think it is now very easy. Let's start with the next one. First, take a screenshot and move further. Okay, so I told you in the promise in the starting itself, whatever the things you have studied, that you have to tabulated form. Okay, so before board exam, before entrance examination, only this table is going to help you. Name of reaction, like Wood's reaction. Reactant is alkyl halide. Reagent is sodium in dry ether. Product. Okay, what is the product? Hydrocarbon with twice the number of carbon atom. Like that, if you make notes, it is going to be very helpful. And if you make a proper and wonderful, beautiful notes and share it to your friends, they are going to be with you, and they will be giving you blessings, and that blessings will work out to pass you with the good marks. Okay, so this is all about the naming reactions of the haloalkanes and haloarenes. Okay, thank you.